Hello everyone. How are you people? Are you guys able to hear me? Yes, no,
Yes.
yes. Okay. So, how is the progress? So, we are in the last module now. We are going to start with the last module. So, before we move on to the next topic, do you guys have any question? Oh, it's all manageable, right? You all can able to manage all these topics. And today it's 20th March. See how quick it is, huh? So everything is all right. So today we'll continue with the next module in the list. Okay. So if you can see before we actually start with our Azure and other stuff, right? Module 2 is something on Azure. This is about your open source DevOps tool, right? So here we are going to discuss about the continuous monitoring and observations, right? So these are things we are going to cover as part of this. So first we need to understand what is continuous monitoring, and we'll see what are all the various monitoring tools available in market, and which one we can use it to monitor the infrastructure as well as applications. And we'll see how to use Prometheus and Grafana along with its architecture, and I'll show you how to install and configure it. And we'll be discussing about the architecture and monitoring using Prometheus and dashboard creations using Grafana. So this is a plan for today. And tomorrow we'll be discussing about our CSD pipeline project using the DevOps tools. That will be, this is for next day. Tomorrow we'll be planning for it.
Can you
So,
speak little loud? It's too slow today.
oh, really?
We can hear you, but it is not loud.
Is that better now or like,
Yeah, it's better.
yeah, I think it's the mic that was a bit far. Okay. So, yeah, fine then. So I think if you can recollect our initial, DevOps modules, right? We talked about the various stages of DevOps. So as part of that, we talked about the continuous monitoring. So almost on day one itself, I gave you the complete picture about what is continuous monitoring and who is responsible to work on this and what is that infrastructure monitoring tool and the application monitoring tool, right? Can you able to recollect? So ultimately, the continuous monitoring means it is used to continuously monitor the production environment and the applications deployed in the production environments. Say for an example, till yesterday, we can able to automate your application builds and deployments in target servers. It can be a Kubernetes worker nodes. And also we have seen how to use your IAC tools like Terraform and Ansible to dynamically create the servers and configure it. Correct? So it's not like we have automated our deployments. Our applications are up and running in production server and we are done with our work. It's not like that. Deployment is just taking your product to the customer. That's all. Once you deploy your application in production environment, it means from that point onwards, consumers or the end users are going to use your application. It can be your banking application or online banking website or your e-commerce portal like Amazon or ATMs, transactions, whatever the product you deploy to the target production server. It means you're just giving it to the customer to use. So it is not like we have shared a product and our work is completed there. Okay, now to ensure the business continuity, there is a very important term. This is to ensure business continuity. Okay, so what does business continuity means? Like consider I'm going to start one web page. Even you can see this documentation itself. Like we have a documentation page. We have a official training page. And also, if you're talking about some real-time environments like Netflix or Facebook or Amazon.com e-commerce portal, all right. So consider I'm an end user. I just want to use Amazon to do some sort of a product purchase or sales. So as an end user, what I'll do, I'll just create an account and I'll start the transaction. So while I'm working on particular transaction, it can be related to the money transfer or any task. Correct. I just initiated it and the website is not responding. What will happen then? Let's say, for example, you're purchasing a product. You have finalized the product and you also paid the bill, paid the amount for the product. As soon as you pay the amount, your amount got deducted from your account, but you're not getting any response from Amazon web page. What will happen then? Hmm? What will happen? What will be the situation there? Hmm?
We'll try to interact with the customer care for the Amazon if possible.
Yeah, of course. We'll try to interact with it. We'll try to interact, and the customer care support team, it is their responsibility to fix that issue, and definitely they'll fix it. They won't say no and all. Definitely they have to address the issue and they will fix it, and it will be favorable for the customer point of view only. Got it? But that is not the question here. At any cost, that service provider have to fix the customer's issue. That is their responsibility, and they will do it for sure. But the question is whether the customer will come back or not. Hmm?
I don't think so.
So that means we are losing the customer there. We are losing the business there, right? So even a small mistake in the production environment will ruin your entire business. So it is not just about delivering a product or taking the product to customer, how the product is reliable. So when you say Amazon.com, that is just a website, but that website includes a lot of resources at the back end. That means it is not just about the website as being alive. The entire resources like the production servers, database servers, networking devices, storage devices, right? So what are all the IT resources required to support that application in production environment should be available 24/7. Then only you can able to ensure that the product is reliable to the customer. Even a small issue in the production environment, it will impact in a huge loss in business. Because one customer face the issue, right? He is not going to stop there. He will just spread it to another customer, right? To all his surroundings. So definitely it will create a huge mess in the business. So to overcome all these things, it is mandatory to continuously monitor the production environment in order to ensure high availability of the production service. Continuous monitoring is required. to ensure high availability of the applications running in the production environment. Easy. Are you clear with this? So this monitoring, it can be at two levels. One is at the production's environment level, another thing is your application level. So it means there are two types of monitoring consider. One is your infrastructure monitoring and another thing is your application monitoring. So when you say infrastructure monitoring, it is something going to deal with all the production servers, IT resources, like starting from your virtual machines, your database servers, everything. And there are some production monitoring tools available, like we have Prometheus, Grafana, Splunk, Dynatrace. All these things are used to monitor your infrastructure. Hope you remember the example which I gave you, right? Any production server will be consuming a lot of resources like CPU and memory. So whenever the memory utilization of the production server reaches 100%, that server will go to irresponsive state or it gets into drain state. It can be an independent production server or it can be the node of a Kubernetes cluster, right? So we have to proactively monitor the production servers by enabling some threshold limit. So let's say if I define a threshold limit as that 75% of CPU means once it reaches 75% of CPU utilization, you'll be getting an alert. Got it? Also for memory. Easy. And sometimes our infrastructure will be up and running as per the expectation, but the application might throw an error or it might not respond. So to monitor applications also, we use something called App Dynamics and Datadog. So these are some tools that is meant for your infrastructure monitoring as well as application monitoring. So have you ever used any monitoring tool?
No.
Have you ever used directly or indirectly any monitoring tool? Like anyone from your batch? Guys, have you used it or it's a question to everyone here?
For
No,
me,
no,
Hmm? No, not it. It's
no.
almost 4 months over, right? We have started the training. It's more than 4 months, what? We started in the, it's just 3 months, okay. So 27th Jan we started. So till now you haven't used any monitoring tool throughout your process? At least indirectly? Yes, no. Very good. So you're all using your Amazon AWS console, right?
yes,
And you have created your free tier account. And it's almost 3 months now. You create the account. And has anyone received the notification from Amazon stating that your resource consumption has reached 85%?
Yes.
Only one yes or like?
Receive.
Huh? So
Yes, receive.
definitely you must have received that notification. If you are not received such notification, it means you haven't practiced anything in this training program. You're just getting the training live sessions recording, that's all. If you properly practice the things, definitely you must have received a notification from your Amazon stating that your resource has been 85% consumed. So how that notification is coming there actually? That is what we call it as a threshold limit. So in Amazon, we have something called AWS CloudWatch. Okay. So AWS CloudWatch is the Amazon's managed monitoring service. This is responsible to monitor your entire resource utilization as well as resource consumptions. Correct. So any resource you create in your AWS platform, it will be attached with the AWS CloudWatch with some basic properties. So if you want to have some additional properties, you can able to customize it. That is secondary. But the basic properties is updated with your AWS CloudWatch, and that is providing the list of monitoring. Correct. So please don't say that you haven't used. That's the reason I asked you. Have you used directly or indirectly? So without your knowledge, every day your CloudWatch is active. It is monitoring your resource utilization. So during interview, if you get such questions, please think and then answer. Correct. So now we'll see about the Prometheus and Grafana. In this training module, we'll be learning about the infrastructure monitoring tool, like your Prometheus and Grafana. Okay. So basically, this Prometheus is called as a monitoring tool. Okay. And Grafana, it is not actually a monitoring tool, it is a visualization tool. What does visualization means? Whenever we monitor the resource, it has to be delivered with some intuitive dashboards. I'm not sure how many of you got opportunity to interact with your monitoring team in your real-time projects. So if you observe any monitoring team, they'll be sitting in front of huge, big screens, right? Monitors. There you can able to see a lot of Excel sheets and pie charts, data that is getting popped up, right? So it is a process of visualizing the matrices, whatever captured through the monitoring tool in the form of intuitive dashboards. So this is to create some monitoring dashboards. That's it. Why we use Grafana means Prometheus is not that capable to create some intuitive dashboards. Prometheus is very good in monitoring. It is having a thousands of parameters to monitor the infrastructure and collect the matrices, like whether it is CPU utilization or memory or resource, right? It monitors each and every entities in detail. It is a monitoring tool. But the data, whatever it collects as part of the monitoring, if you want to create some intuitive dashboards and represent it in the form of graphs and charts, it is not that much effective with Prometheus. For that, we're relying on Grafana. Easy. So first, we need to understand the architecture of Prometheus. As part of this architecture, you can able to understand how the Prometheus works, what are all the components of Prometheus, everything. But I don't want to limit only with Prometheus because the architecture is common for any monitoring tool you use. All monitoring tools works on the same principle. Whether you're talking about Splunk, Dynatrace, or CloudWatch, or AppDynamics Datadog, whatever the monitoring tool you're going to use, every monitoring will be working on the same principle. But its vendor is different. Its user interface, the way of handling the resource is different. That's all. But the underlying process architecture is similar. So if you learn about your Prometheus architecture, in future with this knowledge, you can able to relate and understand any other monitoring tools. Correct. And one more important point on the day itself, I told you, it is completely managed and owned by the infrastructure monitoring team. This monitoring continuous monitoring is owned by the monitoring team. Right. We from DevOps team or development team or any other team part of the system will not have access to create or install the Prometheus or any monitoring tool configurations. We never get access. At client side, they'll be having their dedicated resource and teams to monitor to maintain this monitoring service, and they'll be working 24/7 to monitor production environment. They'll be working in shifts actually. But because even if you miss 1 minute also, it might create a huge loss in business. So there'll be a 24/7 every day, every minute there'll be some monitoring materials collected and it will be managed by the monitoring team. Then as a DevOps resource, why you are learning about this means continuous monitoring is one of the DevOps process, right? So even before DevOps came into picture, right? Like there are a lot of infrastructure monitoring team, they monitor the infrastructure by themselves. They'll be having some manual, process to do that. But now, as a DevOps resource, we are going to integrate our DevOps strategies along with that existing monitoring tools and make it as a continuous monitoring. But without DevOps, they were achieving only the monitoring, production monitoring. But we DevOps team going to introduce how we can able to continuously monitor in order to ensure high availability. Tomorrow, if you want, you can able to integrate this with your Jenkins or any other tools also. Correct. If you want, I'll give you one small example. Like in our earlier case, in your Kubernetes module, we talked about the replicas, right? Replicas.
Yes, replica set, yeah.
It is used to create replicas of your pods. Similarly, we talked about the cluster. It is a collection of worker nodes. So there is something called auto scaling, right? Whenever the network, the access to that pod, it is beyond the limit. Whenever the number of pods which we defined, it is not working as expected, then we need to add more pods. That's what auto scaling means. And I showed you a demo also how you can use it scale command to scale up. So monitoring team will be using the monitoring tools like Prometheus. So that Prometheus will continuously monitoring the incoming traffic, the network utilization of that particular server, and it will have some threshold limit. Through the threshold limit, we can able to give a call to any Jenkins pipeline, and in the Jenkins pipeline, you can have your script ready to scale up the resources. Like this, we can able to integrate our Jenkins, and through some webhooks, we can able to automate this scheduling. That is a process. So in general, what are all the DevOps tools related to monitoring we have means, I'll give you one small example for that. Listen, please. So when we talk about the monitoring tool, listen, please. This is something related to your Prometheus and Grafana integration. So here, using Prometheus, after all, it is just a VM, okay, virtual machine. In this VM, if you install Prometheus, then it is considered as a monitoring server. And any monitoring server will be working on master and node architecture or client and server architecture. So this is a server, and what are all these servers you want to monitor? All those things are considered client to the server. Like using Prometheus, I can able to monitor my VM. I can monitor my Jenkins servers, Tomcat servers, SonarQube servers, or any application servers, containers, Kubernetes, everything is possible. So all these servers are considered as a target to your Prometheus. Correct? It's all target to Prometheus, the client machines. So Prometheus, it will try to pull the metrics. Let's say, for example, I have a Jenkins master node. My requirement is for every 10 minutes, I want to monitor the CPU utilization of that server. So how that metrics can be collected for every 10 minutes means in all these target server, we'll be installing a Prometheus agent. That agent name is node exporter. Node exporter is an agent that should be installed in all these target servers. The purpose of this agent, it is to continuously, extract the data from the target server and send it to Prometheus. For example, if I define a dashboard to pull the rate matrices for every 5 minutes means every 5 minutes it will pull the matrices into the Prometheus server. So node exporter agent, which is installed in the target server, will continuously pull the matrices and sends to Prometheus server. And in this Prometheus server, we'll be having a database. As like we have something called SQL database or Oracle database, here we call it as a time series database. It is a kind of database. And the data, whatever we extract from the target server, it will be stored in this time series database. Once the data is available, right, in time series database, it will be like a raw content, a raw text, which is implemented there. It will not have any proper formatting or meaning. So that data will be sent to your Grafana to prepare some individual dashboards. Because if I present this data to the customers from the Prometheus server, end users or customers cannot understand what it is all about because it is completely a raw content stored in the time series database. So that raw content has to be converted, has to be processed and converted to a into dashboards. For that, we attach this Prometheus server as a data source to Grafana. Correct. So Prometheus server will be having all the data collected from the target server, and that data source is something we're going to attach it with Grafana to create a dashboard. How this data can be extracted from this time series data means there is a query called PromQL query. Okay, PromQL as like your SQL for database, structured data, relation database. Here we have something called PromQL for your time series database. So using this PromQL query language, we can able to pull the metrics from database and send it to Grafana. Got it? So as a DevOps resource, whether you want to learn about this time series database or this query language, no, it is not required. In your lifetime, as a DevOps resource, you never work on all these things. If you're from production support team or production monitoring team, you might be using all these things in real-time environment. But as a DevOps resource, we are not responsible to install or configure any of these components. Correct? So these are the components we have. And between your node exporter agent and the database, there is one component called retrieval component. Retrieval component. That component is something used to continuously pull the metrics, retrieve the matrices from the target server to Prometheus server. Correct? So pull is an action. That action is actually performed by this retrieval component. It will retrieve the data and store it in Times database. And from Times database, we use the Prometheus query language, that is PromQL language, to query the data and send it to your Grafana dashboard. And Prometheus is not just about collecting matrices, it is also capable for alert management. Like I told you, right, every 10 minutes or whenever the threshold limit reaches, we can send the notifications to the end users. So that alert manager is responsible to automatically distribute or share the email notifications. Whenever we get a notification from Amazon stating that 85% resource utilization, do you think it is that mail is sent by someone manually? No.
No.
Strictly precisely.
AWS CloudWatch, it is a monitoring tool which is assigned with your SNS service. That is simple notification service. Through that service, we can able to map any number of email IDs, and that AWS CloudWatch monitoring tool has one component called Alert Manager. Through that Alert Manager, we can able to send the notifications to the end users. So it can be the email notification or Slack notification or webhook notifications. Got it? So this is all about the architecture of your Kubernetes. Any question here? Any question? Fine. So now, how we are going to work on this? So in order to work on Prometheus and Grafana, first we have to install it. So I'll show you how to install and configure it. We can install it in our Linux machine directly in our AWS platform. And from there, we can able to access it through their web services. Right. So what are things we're going to perform here is will be setting up. Okay, you can select this. So here, set up the Prometheus node exporter and Grafana. These are three things you need to do. So this Prometheus will be configured in your monitoring server. It means consider I'm going to create two servers now. One is your monitoring server, VM1. It can be considered as a monitoring server where I'm going to install Prometheus and Grafana. And there is another VM called VM2. Here will be installing node export agent. I told you, right? It is a client server architecture. So if you say this is your Prometheus server, if it is a Prometheus server, then the server which you want to monitor, that will be considered as a target server. Right? So in this Prometheus server, we install Prometheus and Grafana. And in the target server, we install the node exporter agent. Is that clear? And it is not mandatory that you have to install your Grafana in the same monitoring server. Just for sake of demo, we can have it in the same server, but in real-time environment, we'll be having Grafana as a separate node. Why? Because you'll be having a lot of use cases, a lot of scenarios where we use Grafana. Grafana is not just a simple tool, okay? It is a very powerful tool which can integrate any number of resources. So consider, I'll give you one use case, real-time scenario now. Consider I'm using a Prometheus server. What is the purpose of Prometheus server? It will collect the matrices from the target server and preserve it here, right? And if I want to create some visualization, if I want to create some intuitive dashboards, I can use this data as a data source to Grafana, correct? So using Grafana, we can able to connect this Prometheus server and create some intuitive dashboards. Okay. So Grafana is not just for Prometheus. Using Grafana, you can able to pull the data from your Prometheus server, as well as if you're using AWS CloudWatch, it can be an input, or if you're using your Azure Monitor. Azure Monitor means it is a monitoring tool for your Azure. Similarly, your Google Monitor. that monitoring tool also can be attached. So consider you are working in a multi-cloud hybrid environment. So each and every cloud service provider have their own monitoring server, which can monitor its infrastructure. And the on-premises server, we can use Prometheus to monitor. Got it? Now, what are all the metrics we have collected through all these monitoring tools? I want to set up a dashboard. I don't want to create multiple dashboards and multiple screens and panels. One screen should represent all the things on high level. So in this Grafana screen, I can able to prepare a dashboard. And in this dashboard, I can able to create a number of panels. One panel can show the data from my Prometheus server. One can show from AWS CloudWatch. This can be from Azure Monitor or Google Monitor. Like this, if you want to visualize your entire infrastructure monitoring from a single user interface, you can able to rely on this Grafana. It's just one example I'm saying you. Can you able to understand the purpose of using Grafana here? If I'm not using Grafana and if our infrastructure is multi-cloud, then I need to create that many dashboards. A separate dashboard for AWS, separate for Azure and for my on-premises. So just to nullify all these things, we can create an end-to-end resource in single screen. All right. Hope things are clear to all.
Yeah. Okay.
Okay. Now we'll start with the installation process. So to install this, I'm going to create two VMs. And in VM1, I'm going to install Prometheus and Grafana. And VM2, I'm going to install Node Exporter. And one more important thing, Prometheus and the Node Exporter agent will be downloaded as a zip file. It does not get downloaded as a service. So we have to download a zip file, and upon extraction, we have to create a service by ourselves. The service definition should be manual one. Once the service is ready, you can able to attach to your Grafana and access it. So when I say Prometheus and Node port as a service, it has its own port number. Got it? So like Prometheus runs in port 9090 and Grafana runs in port 3100. Got it? Like this, each and every service has its own port number. So once you launch the node, ensure that you properly set up your inbound rule. Clear? So shall we go and install now, or do you guys have any question? So all understandable, right? Yes, no.
Yes.
Okay. So I'll be sharing a separate documentation for you people to set up your Prometheus as well as Grafana in Node. So this is a document. So as like how we have prepared a Jenkins documentation for all those things, we have I have a separate document for Prometheus and Grafana. So launch two nodes. Consider one node as a monitoring server to install with Prometheus and Grafana, and another node can be your node agent. And you have to add the inbound rules. Like as I said, your Prometheus, Grafana, and node exporter runs in its own port number. So 9090 meant for Prometheus, 3000 meant for Grafana, and 9100 is meant for the agent. Or you can simply say allow all traffic. And this is the official page from where you can able to download and install Prometheus. So if you get into this page here, you can able to see Prometheus package available. As I said, it's a zip file. It is not a service file that you can install through apt package manager or yum package manager. It is just a zip file. You have to right click on that zip file, like choose Amazon, sorry, Linux AMD64, copy the link address, and then use wget command to download that. So consider this is the latest version, and if you want, you can able to use the latest version or the previous version which I have in this document. So once you get the URL, hope you know how to get the URL, right? Go to the link, right click on that package which you want to download, copy the link address, and then use wget command to download that package. I just mentioned everything here as a note. And once this is downloaded, use your tar command to extract that file. And upon extraction, you have to prepare a service definition. As I said, Prometheus is just a flat file that you just extracted in your local machine. That means your monitoring server. Now, you have to create a service out of it. So in Linux machine, all the service definitions will be maintained in this directory /etc systemd system. Even if you go through your Jenkins service or Docker service or any service you have, that service definition will be maintained in this path. So in the same path, we are going to create one service called prometheus.service. And this is a service definition, which will be having the unit parameter to talk about the descriptions and documentation of the service. And then the service by which ID you can start, and on restart, when we should restart. Restart the service on failure. It will automatically restart the service. And another important thing is the exec start parameter. So this parameter is used to identify the Prometheus that you have extracted as a executable, and the config file, that is Prometheus YAML, will be considered as a default config file for managing all the resources. Correct. So let me execute this one by one. So let's log in. So let me get into my EC2 instances list, and let's launch a new node. You can launch two nodes here, make it as two, and we like PL monitoring. If you want, you can use any distribution like Amazon Linux. Okay, so Amazon Linux 2 AMI HVM version, it is having a free tier eligible, so you can choose this also, no problem. Or the latest version. The difference here is your latest version uses the latest version of Fedora distribution. You need to use DNF package manager. But if you're using the previous version of Amazon, you can use Yum package manager. Or if you are interested to use Ubuntu, you can use Ubuntu also. That doesn't matter. Got it? Since we already use Ubuntu many times, let's at least try this once. Because the installation process, whatever we're talking here, right? Extraction and processing, everything is common in any distribution. Even if you're using Windows machine also, you have to manually download the package and extract it. Only difference is the package manager name. You'll be using Yum package manager here. Right. So let me launch this node. T2 micro is sufficient for now. Give a tag, choose the AMI as Amazon X2 previous version, and instance type T2 micro, key pair, and ensure that you choose two number of servers. Launch it. It's launched now. So these two servers are up and running now. So let me just tag it as mounting server. And this is my target. Okay. Once the server is ready, the next step is ensure that you properly update your inbound rules. So let me get into the security, what is it called? Security, and go to the security group, edit inbound rule, add, and for sake of demo, let me add allow all traffic. If you're not interested to use allow all traffic, ensure that at least you have these 3 ports enabled. It's mandatory. Right, save the rules. Hope it's clear, right? Like you understand right what is happening here. Now let's go back to our instance list and let me connect to these nodes first. You can use MobiX term. Oh, what went wrong? Any guess? Any guess what could be the issue? Guys? That's right. So here it should be EC2 hyphen user. Okay, sorry. Because we have launched Amazon Linux box. So for Amazon machines, Amazon Linux OS, the default username is EC2 hyphen user. For Ubuntu, it is Ubuntu, right? So this is my monitoring server. And similarly, let's connect to another server, that is your target server. So in my EC2 instance, Amazon Linux machine, I just elevated my access to root level. And as a root user, I'm trying to update the default package by using yum package manager. Similarly, since it's an Amazon product, that will be always up to date. It should be up to date. See, there is nothing to update manually. So now once this is done, you can get into your okay. So let's go to your monitoring server first. And in monitoring server, we have to download that package. So let me use wget command to download that package. I hope you understand, right, how to get this URL. Go to the official page, right click on that service, like Prometheus 3.2.1 Linux AMD 64 version. Right click and copy the link address and implement it. So I'm just running it in my monitoring server in the root user level. In the home directory of root user, I should be able to see that file now. It's available. So this has been, it is just actually downloaded now. Once this is downloaded, you have to extract this using the tar command. So upon extraction, you should be able to see one folder called Prometheus 2.38. I'm using the previous version, so you can use the same. So I just download this package by using the command, and then I use the star command to extract the package. Once it is extracted, you can able to see one folder here. Right, there's a one. If you navigate to that folder, you can see some Prometheus components. Like Prometheus is the executable actually, the binary. And Prometheus.yaml, it is a YAML file that defines the default properties of Prometheus. Like tomorrow, if you want to attach any nodes or target server, within this YAML file, you'll be attaching it. Easy. Now, if I say systemctl status Prometheus, see, it says not found. Unit Prometheus.service could not be found because it is not a service that we install now. We just downloaded a zip file and extracted it. That's it. So we have to manually create a service definition for Prometheus. For that, we are going to create one file called Prometheus.service file. It should be created in this directory. And as a root user only, you can able to perform this stuff because it's all system components. So as a root user, create the Prometheus.services file, go to insert mode and keep all your service definitions. So this unit parameter, that is group value, it is just for documentation. Like you'll be specifying the service description and the documentation and other stuff. And very important thing is your execute start command. So which service it has to start, what is the name of the service, and what are where the properties of service defined, the default property file, that is Prometheus YAML file. So if you're not sure about this description, nothing to worry. What we can do here is just go to that path. You have this path, right? Just go to this path and just give ls command. You will get a huge list of services that is already configured. If you're running this command in Jenkins server, you can see one Jenkins service there, right? So just view the content of the file. You can able to understand this. Only change the parameters, required parameters, that's enough. So we just create the file and save this file. And once the file is ready, the next important thing here is we have to reload the daemon because we have created a new service altogether, a new service in this default directory. This directory has to be refreshed. For that, we have to reload daemon, and then you can check the status of your Prometheus. See, earlier when I use this command systemctl start or status Prometheus, it says could not be found. But now it can recognize the service because we have defined it in this file. But it says it is inactive or dead. So what you can do, you can simply start it. Now if you see the status, it is up and running. So this is another learning for you people, how to create a user-defined service, in which path you can create matters. So now I can see Prometheus up and running. And as we discussed already, Prometheus runs in port 9090. If you want to access Prometheus through a web browser, you can use that public IP address of that server and then port 9090. So let's go to our instance list. This is a monitoring server, right? Take the public IP address of the machine and use port 9090. That's it. It is a Prometheus port. So open your web browser and have this. See, as soon as I use that port number for with that IP address, external IP address, I can see the Prometheus services available. It is up and running. So this is a very simple Prometheus dashboard. A dashboard where you can able to create some custom dashboards and panels, as well as you can able to capture matrices. Here there is something called expression. This field has a lot of parameters, expressions that are required for your PromQL query. Correct. So if there is a command called up or expression called up, just execute this. Enter the expression here and click on execute command. You can see as of now your Prometheus server is not connected with any target server. It is just referring to itself, localhost 9090. Correct. So now we'll see how to attach our target server to this monitoring server. To do that, what you should do? What do you have to do? What we need to install in this target server?
Exporter.
Node exporter agent, correct? So how to install and configure the node exporter agent means it also has its own process. So I'll quickly show you how you can set that node export agent. So if you go to your server, in that server, I'm talking about target server. Okay, just go to the target server, and in the target server you can able to install it. That package also can be available. Can be accessed from your web page. Like here you have your official documentation, right? In this downloads folder directory, downloads page, we have downloaded the Prometheus package first. Scroll down, there are a lot of products available. And in our case, we're going to use Node Exporter. So right click on this Node Exporter Linux AMD64, copy that link address, and then once the ID is ready, use your W command to download it and then extract and then create a service. As like how you create a service for Prometheus, for this Node Exporter also you have to create a service. So let me go to my, this one mobile XTM here. And here, let's download this package. Let me check if this package is available. If it is available, we can use the same. Yeah, it's available. So I have installed Node Exporter 1.4.0, and here I have this file ready. And what I can do here is I can simply extract this. And upon extraction, you see there's a folder called Node. So cd to that folder. And here, if you say ls, you can see there is only one component, Node Exporter components available here. So this is my target server. So here the node exporter is not having any default config file. It is just a small piece of code that runs in the target server. That is node exporter. So what you can do, you can prepare the service definition. As like how we prepared our service definition for your Prometheus server, here this is for the node exporter. Go to insert mode and you can able to update your file here. So as I said, the very important thing is your exe start. Earlier we were using the Prometheus package, but now in the root directory of that particular, root user, you can see there is a folder, and in the folder you can find this node exporter service package. Great. Save this file. So once the file is ready, you can simply say systemctl status node exporter service. See, it is just inactive. So what you can do, you can simply start that service. So now this node exporter service also, it is up and running. Okay, node exporter service. Easy. And this node exporter service runs in port 9100. Okay, so what you can do here is you can go to your server and get in this target server, take the public IP address of target server and use that IP address to set this one. Okay, where is the target server? This This is the Prometheus server. Sorry, this is a Prometheus server. Let me have this here. Okay. In my target server, if I execute it with port 9100, I can see node exporters available. So if you click on the metrics, these are all the metrics that are captured to a Prometheus and saved in Times database. So node exporter agent can able to extract all these information from the target server and send it to your Prometheus monitoring server. It's a very huge list, thousands of entries, expressions will be there. Got it? So practically, we DevOps team will not be part of all these things, but it's just for information how to set up and configure the monitoring servers. What are all the process involved? So with this, we have configured a Prometheus server as well as the target server. Right? Easy. So now, once the target server is configured, if you want to attach this target server to Prometheus monitoring server, go to that monitoring server. And here you have something called Prometheus.yaml, right? Just edit that file. Go to insert mode. And here you can see there is something called static configs. By default, it says the target localhost. Correct? It is capturing the metrics on localhost. So what you can do here is you can use the same notation, something like this. Everything is very documented, okay, for your reference. So here you have to get into the Prometheus server, go to the default directory of Prometheus and edit that Prometheus YAML file. And there you can add one target. Now the target is this target server. Take the private IP address of the target server and have it here. See, that's it. So this has to be updated in your target server. Sorry, in your Prometheus.yaml, this one. You just update the IP address, right? Just I have it here. So what I'm going to do here, I'm just attaching my target server as an agent to Prometheus. So save the file. Guys, hope you all following, right? Or any confusions here? Now you people are busy. I mean, comfortable in Linux commands, right? You can able to follow.
Yes, see.
Yes.
Yes.
Okay. So now we have just updated the Prometheus YAML file. Whenever you make any changes in this default config file, you have to restart Prometheus. And ensure that it is up and running. Now, once the Prometheus service is restarted, if you go to the web page here, and earlier it was just pointing to the local host. Now, if I execute the same command, it should say my target server ID also, because we just updated there. So this is how we can attach our target servers to your Prometheus monitoring server. Hope it's clear. Even if you follow the document, it's very much crystal clear. Okay, just step by step follow this. It's easy. Okay, that's it. So this is how we can set up your target server and the Prometheus monitoring server. And if you see here, there is an outcome of this expression up this expression details. Like this, what are all the expressions we have here, and how we can able to manage all those things means we are not going to deal with all the expressions, but at least on daily basis. Like if I want to capture the CPU utilization or memory utilization of the server, like this, you can able to write some expressions. You means a monitoring team, not DevOps team. And if you want to learn about this, let's say this is a query to capture the CPU utilization of the server. If I enter this value, you'll be getting some matrices. So those matrices are saved like this only in time series database. If you click on graph view, there's a graph. Let me customize to last 10 or 5 minutes. See the CPU utilization of this server, it is something like this. And it's not something new, okay? Like in your AWS, if I say here, this is an instance, right? In any resource you create, you'll be having a monitoring tab here. Can you see this? So this PL monitoring server, that is just a VM, and that VM is actually being monitored by the AWS CloudWatch service. So CloudWatch agent namespace is running and it is capturing CPU utilization of the server, network, network out, and other parameters. So this is what we call as a monitoring dashboard, and each and every piece here we call it as a panels in the dashboard. Correct. Panels are used to define the properties, individual properties of the server. So same kind of dashboard, if you can able to create using Prometheus means it's not possible. Because Prometheus is not meant for preparing some intuitive dashboards as like CloudWatch, but it is very much powerful in capturing the metrics from the target server. So from where you can able to learn this expression means it's very simple. There is a page. There is also official page from Prometheus. So from this page, you can able to get the query, that is time series prompt kill query. Correct. From here only even I took these things. Like this is for CPU utilization, and this is for memory utilization. This is for to capture the system boot time. All these things can be captured from this expression list. Okay. Any question, guys? Any question on this? If you find time, just go through it. Otherwise, it's optional, completely optional. So now we have configured our Prometheus server and also attached the target server with Prometheus monitoring server. And whenever you execute your PromQL query, you can able to capture the matrices from the target server, and your Prometheus server can able to represent the data in this manner. But this is not that intuitive. See, it is getting updated, like how the resource is getting utilized. These metrics is what you're seeing on screen, right? So these metrics is having its own unique, references of the resource utilization. But this is not that intuitive to prepare. So what we can do means you can, if you want to prepare such AWS CloudWatch kind of dashboards, you can attach this Prometheus server as a data source to Grafana. So the next topic in the list is how to set up your Grafana. That is the thing. Okay. So I repeat, First, we have configured a Prometheus monitoring server, create a service, and then in the target server, we install node export agent and then configure that server. So now both these services, Prometheus service as well as node exporter services up and running. That's the reason you can see this pages and all, right? Now, the next step is, in order to create some intuitive dashboards, we can use Grafana. So how to install Grafana means this is the official page to install Grafana. So in this page, you have something called version, the latest version or any version you can choose. And here they have two editions. One is enterprise edition, another thing is your open source service edition. So if you want to implement at enterprise level, you can go with enterprise edition because it's a paid service. Correct. It is a paid service. You can go with enterprise version. But if you are using this just for learning purpose or to understand the capabilities of Grafana, you can go with open source service, which is free. Correct. Ensure that you choose open source service before you download the package, okay, for Grafana. If you use this one, it will expect you to create an account first, and then it will expect you to pay the required dollars. Okay, don't get in the situation, just use open source service edition. Now, how to install this means they're given a complete process. Like if it is a Linux machine, and if you want to install Ubuntu, just execute these lines of code. Or if it is RHL CentOS, just run these lines of code. Like this depends upon your distribution, you can implement this. Can be used in Windows, Mac, or any other environments. Any question here? Okay, any question on setting up your Prometheus and node export agent? Are you comfortable with these two things?
If we want to connect more than one target server, so we have to add the private address there at the same time.
Yeah, that's right. You can add one more target followed by that target IP address of the target server.
So when we will execute, then how we will know then from which target server it will execute?
That is where you use expressions, right?
Okay.
So using this expression, you can able to apply the filter and access it.
Okay.
Correct. So if you are interested to do that, just go through these expressions. That there are a lot of queries available here. So you can able to apply some filter and handle those parameters. Now, to set up your Grafana dashboard, first you have to install Grafana. And since we are using Amazon Linux machine, we'll be using like Yum package manager, right, to install. No need to download and all, just directly use Yum package manager to install it, will work. Because it is a package that gets downloaded and installed using a package manager itself. Or if you want, you can download and install. That's also possible. And as like your Prometheus and node exporter, here you can run Grafana as a service, but the point is you don't need to create a service definition for Grafana. It is something as like Jenkins. Jenkins, as soon as you install, what happens? It will create a service, right? Similarly here, Grafana will create a service and by default it runs in port 3000. All right. Okay. No problem. If you want, just have a quick break and come back. I'll show you how to set this Grafana. 5 minutes. Go ahead, please. So if you have any question, please. Yes, mouse in water trying there. Okay, so shall we?
Yes.
Right. So now that our Prometheus and server and the node export agent is up and running in the target machine, but only problem is I'm unable to prepare such an intuitive dashboards as like how we use our CloudWatch. So to create such dashboards, we have to configure the visualization tool called Grafana. So this can be downloaded and installed in your monitoring server itself, like in the server itself, monitoring server. Here, I just want to install this. So if you want, you can able to download the version and install it if it is available, or you can directly use yum install to install the package. Anything is possible. If that package is available, you can install this. You can directly run this command. Both are same actually. Just say Y to proceed further. And now Grafana is installed. Once Grafana is installed, right, you can able to check this service. I mean, you need to enable service first. So all these commands are used to enable the Grafana service definitions. Right. See here, we are just enabled Grafana and it is all up and running now. So once the service is up and running, you can take the external IPs of that machine followed by the port 3000. So I've installed my Prometheus server, right? So this is a monitoring server. Take that IP address, public IP address, and update it here with your port number 3000. So if you run this in your web browser, you should able to see your node export, Grafana services available now. So this is the welcome screen to Grafana. And it is expecting username and password, right? Just simply say admin. Space and password also is admin in small case, ADMIN. So this is a default user ID and password to Grafana, right? So once you enter this username and password, it will expect you to change that password because that is a default credential, right? Whatever you entered, default username password is admin. And if you want, you can able to change it on the next page. Give your own password and confirm the password. Or if you are not interested, simply skip this. because I'm not interested, because just a dummy server. I don't want to change the password now. So I just skipped that parameter and it just took me to this dashboard welcome screen. So here you can able to see something called data source, because we have to add Prometheus as a data source to Grafana. Grafana is running in service 9090. Sorry, Grafana is running in port 3000. Prometheus is running as a separate service, right? So what are all the contents that are extracted by Prometheus? You have to send it to Grafana. For that, first you have to add Grafana as a, Prometheus as a data source to Grafana. So to add Prometheus as a data source, you can go to this home page of Grafana, click on data source. And here you can see Grafana supports a huge list of data sources. It is not just Prometheus. We have Graphite, InfluxDB, Open Time Series database, and also we have some logging tools like OK and Elasticsearch. And as I said, it can able to monitor your additional cloud resource also. Like you can attach your Azure Monitor, CloudWatch, Google Cloud Monitoring tool as a input to Grafana. And your database servers also, MySQL, PostgreSQL, and also you can see App Dynamics, Azure DevOps. So it is a huge list, okay, which can be integrated with Grafana. But whatever it is, the process same. That is the reason most of the customers are relying on Grafana today. Okay, it is a very much intuitive to prepare the dashboard for presentations and all. So now in our case, we are going to use Prometheus as a data source. So to create a Prometheus data source, go to the data source option and select Prometheus. See, there's one. I repeat, from your home page, click on data source and click on add data source as Prometheus. That's it. So now data source has been added. And once it is added, if you want to customize this, you can see it is expecting the Prometheus URL. So the Prometheus URL is this one. Right. So this is the Prometheus URL. You can have it here. So this is a public IP address of my Prometheus server followed by port 1990. And if you configure this Prometheus server with some credentials, like it can be a key-based authentication or token-based authentication, you can able to update that authentication parameters here. But since both Prometheus and Grafana are running the same server, this parameter is not required here. And all of the parameters will be default. And click on save and test. So now the data source is updated. It is working as expected now. You see, this is all about setting up your Prometheus as a data source to Grafana. Got it? Now, once this is completed, you can go to your dashboard. That is the home page of Grafana. And from here, there is something called a context menu here, the dashboard. Just click on any of these things. Like you can go with your new dashboard, for example. From your context menu, just select dashboard and click on new dashboard. So as I said, dashboard means a collection of panels, right? If you can see, you're monitoring AWS CloudWatch. This is actually a dashboard composed of various panels. Like this, here also we can create a panel. Just click on add new panel here. And here you can able to see the panel configurations. So first thing, ensure that your Prometheus is added as a default data source here. If you added Azure means from this dropdown you can choose Azure. If it is AWS, you can use AWS CloudWatch. Like that, identify the data source first, and then there is something called code tab here. Because Prometheus is based upon time series database, the data can be pulled from this Prometheus server using that PromQL query expression. So to enter the query expression, click on this code tab and open up one text box. It is actually a multi-line text box where you can able to enter the query expressions. Like earlier I was showing a CPU utilization, right? Let me use the same here. That's it. Okay. That's it. Now, on the right hand side, you can able to choose the visualization effects. Like what type of chart you want to prepare. By default, it is time series chart. That's why it is represented here. And if I say for last 15 minutes, this is how the time series chart is defined. Or if you want to have a bar chart, change the pattern. Like this, we have an option to customize our charts here. It's possible. Okay. So all the things, utilization, everything can be captured in this manner. And this query is something meant for CPU utilization. So I can simply give a page title as or panel title as CPU utilization and apply the changes. That's it. You can able to customize this. So this is something similar to your service, whatever we have here, right? Similarly, if you want to create another panel for system memory utilization means no need to create it separately. From here itself, you can see there is a drop down. Use this drop down and click on more, duplicate it. Similarly, in this duplicate image, go to more and duplicate. Like this, we can able to create some custom dashboard panels. So if you want to work on this particular clone, select and edit. Now you can change the name of this. Let me give it as a memory utilization. And what is the query for memory utilization means? This is what it is. This is a time series query expression to capture the memory utilization of that server. Simple. Okay. And if you want, you can change the expression here. So this is how the memory utilization is there actually in your server, like bar chart or time series chart, anything for your reference, and save it. Yeah. So like this, using Grafana, we can able to just compare it here. Like if you are creating Grafana dashboard, this is how the changes or representation will be, right? But if it is a Prometheus, it's a very flat image. Okay, we don't have any other we don't have any other customization here. It just handles the data. That's it accurately. But this is something used to prepare some intuitive dashboards. So any question? Guys, any question? So in real-time environment, as a DevOps resource, what we can do here means we will not have any access to install or configure Prometheus or node agents or your Grafana kind of thing. Let's say I have a Jenkins servers. I have Jenkins master node. I have some Jenkins slave nodes. And as a DevOps resource, I want to monitor my Jenkins servers. Got it? So if you already have knowledge on creating a dashboard, only dashboard creation access will be given to you. Because creating a dashboard means it is not making any changes there. It is just trying to read the data and create some intuitive dashboard as per your team's requirement. So every DevOps resource will be having a privilege to prepare the dashboards in real time. But even if you think you cannot make any updates on that server, you cannot make any changes. Let's say I want to apply some filter based upon certain filtration criteria, means it is not possible for you. To do that, you have to place a request to your monitoring team. And once the request is approved, then only it can be implemented. Understood? Any question? So this is all about your Prometheus and Grafana as per your course curriculum. But I strongly recommend, right, in future, if you get an opportunity to work on such monitoring tools, just try with the Dynatrace once. Dynatrace. Okay, Dynatrace also, it's another monitoring tool. And using Dynatrace, we can able to monitor the production environment. You can create some dashboards, everything. So, but it is a paid service. As like Prometheus, you cannot access or create some metrics directly. It is a paid service. Correct. So all clear? Guys, any other question? Any other question also? I'll be sharing this document. This will be helpful for you to understand the installation and configuration of a Prometheus Grafana as well as your node export agents. Guys, any other question? And if you are preparing for interviews and if your main objective is to get into your DevOps role, focus more on exposing your DevOps skills. Okay. Don't share more about your Prometheus and other stuff and all. Just mention like you have some training knowledge on these tools. Don't mention like you have hands-on experience in Prometheus and Grafana and all. If you're preparing for DevOps role, or if you are preparing for your production support or monitoring, yes, you have to talk about Prometheus and Grafana more, along with some experiences that you work in real-time environment. But for DevOps resource, do not highlight these skills even in your resume. Okay. Any questions, guys?
Looks like after the completion of the CI/CD projects, which will start from tomorrow or maybe day after tomorrow.
Not
Uh,
maybe day after tomorrow. Tomorrow we'll be discussing about it. Tomorrow we'll be covering that.
yeah.
Okay,
So
now itself I'll give you the overview of what we're going to do tomorrow. Tomorrow will be a demo actually. So now I'll be giving you a quick overview of it, and then we'll proceed with the demo in the next session. And day after tomorrow, that means you mean the Monday, right?
yeah.
Uh, by the time you'll be starting with your Azure or the next module in the list.
So all right. So I think we need to get in touch with. I personally need to get in touch with the Paper Live team because you have already completed all these modules, but you know, maintaining it with our office and all that stuff, it's pretty difficult. At least 3 or 4 days in between, the team should give us to practice all the modules again, because jumping onto the other modules, back to back, I don't think it will stuck in my mind. It's pretty difficult for me to you know, cope up with all the things.
That is what it is. It is your own concern, right? Not the
Yeah,
whole team's
yeah, it's
concern,
not
right?
yours at all. Yeah, you are
Yeah,
absolutely right.
then it's fine. You can talk about it. You can check with your support team. They will help you to,
Hmm.
mitigate that issue. Hmm?
From Monday, you will be starting with Azure, right?
Monday, yeah, as of now, there is a plan.
But if it is in your plan, you will definitely execute it. I know.
So for DevOps, we need to highlight Jenkins. Yeah, that's right. So if you are preparing for a DevOps role, I strongly recommend mention your Git, Jenkins, Docker, Kubernetes, as well as Terraform and Ansible also. Correct?
Yeah.
And focus more on Docker and Kubernetes and Jenkins.
Okay.
Like for example, if you are preparing for interview, if you are preparing like a 1 year of experience or 1.5 years experience resource means, you can say like, I worked in Jenkins. I am responsible to manage Jenkins server, starting from installation configuration. Hope you remember, right? I given the
Yeah.
set of rules and responsibilities, right?
Yes.
Those things. So ensure that you understand all these things, and that is what you'll be doing in real time also. So as the 1.5 years of experience with the Jenkins resource, you can highlight all those experiences in your profile. It definitely add value.
Yeah.
Correct?
Correct. Hmm.
Fine. So
So just to
So,
for
just to
freshers, you'll be considered as a trained DevOps resource. If you're a fresher and if you're, I think your next month your exam is going to get over, right? So once you complete your graduation, you just prepare your profile and update as a fresher. You have done this training and you did this project. You're comfortable in all these tools. And in the project, you can mention all the roles and responsibilities. Definitely your profile will stand out from the crowd.
Loksa, I just have a question based on the Linux.
Hmm.
May I ask?
Yeah, yeah, please.
I created some users in the Linux, and if I am trying to remove them, I am giving the command to remove them, remove command, rm command, and still I am able to see all those users in the PASSWD folder under the etc
You should delete
directory.
the user, right? User del.
User del.
You can use delete user command. That is a command, not rm.
Oh, user del followed by the username.
Yeah,
As a root user, I need to.
yeah, as a root user.
Okay, and then I won't be able to see that under the PASSWD folder.
Yeah, yeah.
User del followed by the
So
user.
here I can, okay, yeah, that's right. So can I remove these servers? Are you comfortable with these things? Like your Prometheus and Graph? I'll update these documents, okay? Like, let me upload this to your
Yeah.
repository. So in the training documents folder, I'm going to prepare a new directory for monitoring. Okay, this is for Prometheus. It's a very important thing. And for your class notes, today's Prometheus and Grafana class notes, you can consider this one. Okay, easy. So you can see it in your directories, respective directories actually. In your monitoring, you have it. Okay. So the next important thing in the list is about your CSD pipeline project discussion. So this is our last thing, which will give you a complete picture about integration of all those servers. Okay. So listen carefully. Consider I have an application team wants to onboard their application server, application to DevOps. DevOps pipeline. This is to perform automated build and deployment in Kubernetes cluster. Correct, that is a requirement. So in real-time environment, if you want to achieve this, first we have to do a detailed assessment about that application and the service. Like what type of repository they use, how they have organized the repositories, what is the default branches, what are the properties and protection levels of the branches. And when it comes to your automated builds and deployments, what are all the servers you need, and what are all the tools you need to install, and apart from that, what are all the actions you're going to perform in each and every server. So you have to properly create a plan to execute. Without proper plan or assessment, if you start your DevOps implementation, 100% it will be a failure process. So before you actually start any DevOps solutioning part, please ensure that you understand the requirement clearly and then document it. Whatever you understood, just document it and then implement one by one. Correct. Customers might be in very hurry. They want to implement it. Say if they have around 500 applications, means they want to implement DevOps for all the 500 applications. And they expect to be happen on same day. This is not at all possible, because DevOps is all about the continuous improvement. Step by step, we can handle the application and implement one by one. If there's any issue occurs, learn and rectify it. That's all. Easy. So now on DevOps perspective, if you try to handle this kind of projects, first thing you will be doing your detailed DevOps assessment. Okay. So once that assessment is completed, the next thing is you, based upon the assessment report or summary, you have to identify the list of servers. Correct. You have to identify the list of servers to implement CI/CD, and then you need to identify the list of tools to be installed in all these servers. And the next thing is you have to integrate the servers. Then only the server can able to interact with each other and do some sort of communication, interaction will be there, implementation will be there, right? And once you're clear with all these things, then only you should create a CI/CD pipeline, scripts and templates. Correct? So it is not like as soon as I have an application, I can directly create a pipeline and implement. It's not at all possible. There should be proper steps to be followed. So any question in this process?
It's clear.
Okay. So now, as part of my assessment, I found the application, and to perform the build, what are all the servers I need to create to automate a CI/CD or to implement CI/CD? What are all the servers we need? That means your VMs needed. So what all servers you need? What is the purpose of each and every server? Okay. So everything should be properly analyzed and documented. Because only if you know the purpose, you can able to install the required tools. Correct. Let's say, for example, I have a server. That server is going to perform the application build, means that is the purpose of that server. Okay. Once you find the purpose of the server, then you can able to easily identify the tools that you want to install in the server. Correct. Once the tools are installed, using the tools, we can able to create a pipeline and we can able to enable proper integration between the servers. Now, a question for you people. You guys are aware of the final result, CI/CD, correct? Ultimately, we are going to prepare a CSD pipeline project for such application. So whenever we talk about the pipeline project, right? My requirement is I want to perform the automated builds and deployment to my Kubernetes cluster. I have a Kubernetes cluster, and in that cluster, I want to set up all my resources automatically. So in any pipeline project, there'll be some sort of stages, right? Yes or no? Any pipeline project will be having certain list of stages. So for this particular requirement, what will be the very first stage?
Checkout, SQL check.
Okay, SCM checkout. Then what is second stage?
Build.
Build the
Build.
artifact.
What you're going to build?
Yeah. Artifacts.
So application build, right? Application artifact, the application build. And once the build is completed, what is the next stage in the test, in that tool, in that service or a pipeline?
We need to deploy in the target server.
What you want to deploy in target server? What you want to deploy?
First, we need to
Artifacts.
create the. I think we need to create the image.
That matters, right? Because the requirement is automate the builds and deployment in Kubernetes cluster. So we have performed the build, application build. So here we just get the source code, and based upon source code, we can perform the application build. Like you'll be getting the build, that is your war file, something like this. And I'm not supposed to directly deploy this war file to the target server. It should be deployed to the Kubernetes cluster. And in order to deploy application Kubernetes cluster, I cannot directly copy the war file to my Kubernetes cluster. Instead of that, I should perform the application image build, correct? I have to build an image based upon this war file. Agree?
Yeah.
Yes.
Yes.
And once once the image is created, so here I'll be getting the app image. As part of this stage, I'll be getting the app image. And once the image is ready, what next?
We need to put them in the containers or pods.
Eh?
To containerize the image, we need to containerize the image.
No, we have to deploy in pod.
Please be louder, deploying.
Pod.
How can you
So
deploy your
building the
application
image,
image to pod?
it is done by using the container.
See, build is
It's
completed
storing
here.
it
When
in
I
the
say
repository.
application image build, it is completed.
Yeah, the Docker part is
Docker
completed.
part, the image creation part is completed. Assume that this is the image name, app image is created now. Once image is created, what's next step? In your Docker module, you use Docker build command, right?
Yes.
You use Docker commit command, right? So as part of these commands, you must have created some images. Docker container images, and what you did with that image? Have you pushed it into your Docker Hub
Push it
registry?
into the repository Docker
Regi-
Hub.
That
Register.
matters. So once the image is
Re-
ready, let it be like a v1.0, the version. Once this image is ready, just push this image. So here, as part of this, you'll be creating your image. Publish. Once this is published Docker, what next? You are going to deploy the application images to Kubernetes cluster. Easy. Hope it's all clear to you people. So in my pipeline project, I can have 5 stages. So these 5 stages are more than sufficient to quickly perform build, create artifacts, and deploy to target server. See?
Yes.
Okay. Now, these are all the stages that you are going to have in your pipeline. But to execute these stages, what are all the servers we use? And what are the tools you're going to install in each and every server? And how you're going to integrate it? That is what we're going to learn in the next session. So the next session, I will show you how we can able to set up your Jenkins master node, your slave nodes, as well as your Kubernetes cluster or any application server that is available. I'll show you a demo to integrate all those things and come up with the end-to-end CSD pipeline. See, you okay for today? Yes, no.
So these are all the steps under the CI/CD pipeline project creation.
This project phase is something additional because as per your process, if you can see here, once the monitoring is completed, we'll be moving into the next level, that is Azure. But before I get into Azure, I'll just give you a fair idea about your project phase, like how we can implement it. If you understand this process properly, you can implement the same with your Azure, AWS as well. Google. Okay. So as part of today's session, ensure that you understand what is monitoring tool, what is the difference between infra monitoring and application monitoring, what are all the various monitoring tools available in market, and how to set up your monitoring server, whether it's a Prometheus server or a Grafana or node export agent. Just follow the procedures, whatever is shared, and try to create it. All right. And at any point of view, you can able to customize your dashboard. Even the most effective way, we can able to handle through your nodes directly. Nodes instance your target server. What are the servers you have, right? Just maintain your agent, the node, and handle your matrices. And when it comes to your project, just go through this. Tomorrow I'll repeat all those things and I'll show you a demo of how we can implement this. All right. Any question?
Yeah, yes, I have. So after application build, won't we deploy artifact into Tomcat server?
That was your very initial thing you did in Jenkins model, right?
Yes.
There, during your Jenkins CSD pipeline project, we never discussed anything on Docker module, correct?
Yes.
So without containerizing application, If you want to do the deployment, means directly you can copy the WAR file to the target server. That is deployment. But my
Okay.
requirement but my particular concern here is we are going to prepare an automated builds and deployment in the Kubernetes cluster, not to any target Tomcat server, as what you did in your demo. Got it?
Got it.
So for that only we have to process all these details.
Okay. Fine, sir. Thank you.
Yeah, sure. So any question? All good or like? All right, guys. Thank you. If you don't have any question, we'll close this call. Tomorrow, be on time. We are going to learn many things on this project. Right? And please come up with some questions, okay? All right, guys. Thank you.
Thank you.
Thank you.